Hi! After we learned to refine synchronous and asynchronous processes in SD1, the first detail level of an OPM model, it's time to learn how to refine objects. With this last piece of knowledge, you will be able to model an electric car system that will adhere to the strict standards of ISO. Let's go back to the model we created for alerting the driver regarding dangers on the road. We refine the main process of this system as asynchronous by unfolding it. In our model, the system is an object that serves as an instrument of the main process. It exhibits the attribute representation set, another object in its own right. This object consists of three parts: vehicle in front representation, pedestrian in front representation, and lane set representation. We refine the object mobilized system into four objects, three parts and one attribute. If we wish to group the entire structure of mobilized system into a single OPD, we can do this by unfolding the refined object. Let's do this now. Good! We created a new OPD which shows us the system structure. It only includes objects, not processes. This diagram shows an object tree, the main object, the refinable, and its refinees, its parts and attributes. Now let's turn to another model we created, a synchronous process of the same system to learn about state suppression and expression. Here we can see all the possible states of vehicle in front representation. However, do we need this in SD? After all, we have used an effect link which only tells us that the linked process somehow changes the object from one state to another. Only in SD1 we show the details of how specific subprocesses change these states. Therefore, in SD we shall hide the states or suppress them to make the OPD simpler and easier to understand. In general, we should suppress or hide states that in some OPD are not linked to any process and therefore do not add to our understanding of the model when looking at that OPD. Notice that when one or more states are suppressed, a pseudostate, a small state with three dots, appears at the bottom right corner of the object, indicating that the object has at least one more state which is suppressed. For this model, there is no need to show any state of vehicle in front representation in SD, so we shall hide them. Now all the states are suppressed. However, in the first detail level, SD1, the states are still expressed and we can see them linked to the subprocesses that change them. Very good! Before saying goodbye for now, let's discuss a central concept in systems engineering called emergence. Emergence is the appearance of a capability or functionality that characterizes the entire system, but not any one of its constituent parts. A good example of emergence is the road danger warning system, which we modeled in a previous unit. The system consists of many parts, objects, and processes. For the system to perform its function and fulfill its purpose of lowering the probability of a crash, all those parts must be coordinated and work together. If we were to separate the system into its various parts, they would not be able to do what the system as a whole does. The combination of the system structure and behavior which gives rise to its emergence is the system architecture. Through emergence, the system's architecture enables it to function and deliver the benefit to its beneficiaries. This was what we have done so far. We began with SD and its related components, purpose, function, enablers, environment, and problem occurrence, and refined it in SD1. See you soon!